Hello everyone. In this video we will be discussing potassium dichromate. It's a part of class 12 DF block elements. Okay, and it's an important topic because generally in board exam you'll have 3-mark question from here. That is the equation. Okay, but we'll be covering everything about potassium dichromate. So the first potassium dichromate K2Cr2O7, you have the uses. The two important uses are it's used in leather industry, right? So that you should just have an idea because now you have even MCQs in your syllabus, so maybe it is asked. So it's a very good oxidizing agent used for the preparation of azo compounds, and moreover in complete organic chemistry you have used many a times potassium dichromate is a very good oxidizing agent. Okay, so we'll also discuss like why it's a very good oxidizing agent. You can check the oxidation state of chromium. Chromium oxidation state is +6. +6, which is the highest oxidation state chromium can have. Chromium configuration, children, you have already seen it is 4s1 3d5. So the highest can be the sum of the two. That means the 6 is the highest oxidation state. Right, as an oxidizing agent itself has to reduce. Because this is the highest which it can achieve. It cannot go beyond 6. It cannot go beyond 6. So it has to act as an oxidizing agent because this is the limit up till which chromium can go. Beyond that, if it is a reducing agent, it has to oxidize. It cannot go beyond 6. So if any element is exhibiting the highest oxidation state, it will be acting as an oxidizing agent. So it's a good oxidizing agent. Okay. The next important topic in this is the preparation. Preparation of potassium dichromate from chromite ore. If you are asked from chromite ore is FeCr2O4. Okay, if you remember these three equations also it is fine, but otherwise I just wrote here what is happening in it. First thing is this potassium, this iron chromite which we have taken, chromite is fused with sodium chromate, right? It's given here by the fusion with sodium carbonate, not chromate. This chromite ore is fused with sodium carbonate in the presence of air, in the free access of air. So these three things are there: chromite ore, sodium carbonate and oxygen. What you get is a yellow solution of this. This is the color. Sometimes children it is asked in terms of ABC. Chromite ore is reacted with this, forms A, which is yellow color solution. So the color is your, clue to the answer. Okay. So till here it is the yellow color solution. This is obtained. Now that yellow color solution is treated with acid. It is acidified. On acidifying it forms orange color solution. So this is orange color. Okay. So first what you are getting is sodium chromate. The main thing is Na2CrO4. Plus apart from that you are getting this plus Fe2O3 plus CO2. Then this yellow color solution mein you are adding acid. So till here was the first thing, first step. The second step was this is acidified with the sulfuric acid and you get orange color, put sodium dichromate, still it is sodium dichromate. Now comes the third step. Third step is you can prepare this by treating the sodium dichromate with KCl. This is the third step. So 1, 2, 3 equations if you write, that is enough, children. Okay, so this potassium dichromate can be prepared by treating sodium dichromate with KCl, and now it's just exchange of ions taking place. Now Na ke saath you will have Cl and with K you will have dichromate, and this is also orange color crystals you get it. Okay, so chromite ore is FeCr2O4 with sodium carbonate and oxygen, it forms sodium chromate. Sodium chromate acidified gives sodium dichromate. Sodium dichromate with KCl forms potassium dichromate. Another important thing is, this is the second point. The first was I told you uses, the second was preparation. The third point I am telling you is chromate and dichromate are interconvertible based upon the pH. So to chromate, which is yellow color, this is yellow color. To that yellow color, if you add acid, it forms orange color dichromate. And again to that orange color dichromate, if you add base, it will form yellow. So it is what? This is yellow. It can turn to orange by adding acid. that orange color on adding base will again become yellow. You can try this out in your labs also. You can take potassium chromate, you have it in the lab, which is yellow color. You add acid to it, it will become orange color dichromate. The orange color dichromate, again you add base, it will form chromate. Got it? So this can be an important question again. Now we move on to the next topic, that is the structure of chromate and dichromate. Okay, this is chromate. Chromate is CrO4 2-. Its structure is given here. It's tetrahedral arrangement, so you can draw either this or this one. Either you can have, now instead of this showing here 2-, what you can do is you can write chromium in the center, 4 oxygens in a tetrahedral arrangement, 2 oxygens with a single bond. The 2 oxygens with a single bond you can show minus, and the remaining 2 oxygens you can show a double bond, because 2 oxygens are having one bond, that will be negative charge. Whereas you can have one more, this or this, not both, any one you can draw. You can draw all chromium, 4 oxygens in tetrahedral arrangement, all single bonds, and close it in a square bracket and 2-. It means that the 2 negatives can be on any of the 2 oxygens, and the remaining 2 oxygens will be double bond. The 2 oxygens which are having single bond will have negative, and the remaining 2 oxygens will have a double bond. Then next, this is yellow color. Again I am saying color is important. Chromate is yellow color and dichromate is orange color. This is orange color. We have this both in the lab. Okay, the next comes dichromate. What it contains is, there are 2 tetrahedras, right? There are 2 tetrahedras, one oxygen in the center. This is better, visibility wise. Chromium, 2 chromiums, 4 oxygens around. 1 oxygen of the tetrahedron is being shared between the 2. And the 2 oxygens with each chromium with double bond, and 2 oxygens, total 2 oxygens, but 1 on each chromium. 2 oxygens on each chromium with a double bond, that is 2 double bonds here, 2 double bonds here, and 1 each chromium is having single bond oxygen with 1 negative. So 1 negative this side, 1 negative this side, and 1 interlink between the 2. The angle here is 126 degree between the 2. This is CrO, Cr. This angle is 126. This bond length is bigger. This O and Cr bond length is bigger. It is 179 picometer. Whereas all other, that external ones, chromium oxygen, they are all same. They are all equal, 163 picometer. At times, this can be also asked, are all same? No, they are not all same. 2 are 179, which are longer because they are not double bonds, and the remaining 2 can be double bond, because it's not necessary that this oxygen should be a single bond. This can be single bond with negative, this can be double. So they are all resonating structures. So you can have all other chromium oxygen bond lengths 163. These are all 163, and in the center ones are 179 picometer. Got it? So this is about structures. We have done 3 topics so far. One was the uses, then we did preparation, then interconvertible nature, and the fourth one, now the fourth one was the structural aspect. Okay. The next topic which we are covering is the oxidizing agent. Okay, so this is sodium or potassium dichromate. They are very good oxidizing agent. The reason I already told you why they are good oxidizing agent, and they are also used in volumetric analysis, that is in titrations. Now you have only one type, that is in acidic medium. This is a balanced equation, but you need not learn the balanced equation as such. You can balance it there and then. Okay, so what you will learn is ki dichromate, that is Cr2O7 2-, as an oxidizing agent itself is getting reduced to Cr3+. As an oxidizing agent, dichromate is getting reduced to Cr3+. This you will learn. And you can balance it on your own, following the steps which we have already done in redox reactions, that is half reaction method. Balance other elements first. Other elements means you will put 2 chromium here. Other than O and H, we'll put 2 chromium. After that you have to balance oxygen. For balancing oxygen, you'll have to add water molecule. So there are 7 oxygens, so you will add 7 water molecules on this side, the deficient side. Then we balance hydrogen. Acid medium, we balance hydrogen by adding H plus. There are 14H this side, so you will add 14H plus on the left hand side. Then you will have to balance charges. Check the charges on the left hand side. Charges on the left hand side are plus 12. You can check minus 2 and 14 into 1. So 14 minus 2, 12. On the right hand side, the charges are plus 6 because water is neutral. So this is 3 into 2, 6. So to balance electrons, you will add on the left hand side 6 electrons. Okay. So this is acting as an oxidizing agent. So itself is undergoing reduction. Reduction is gain of electrons. So 6 electrons have to be added on the left hand side. Otherwise, you have just followed the normal technique how to balance it by ion electron method. So your overall equation becomes the same. What is written here? Cr2O7, 14H plus 6 electrons, 2 Cr and 7 water. You will balance this separately. And then you will see that dichromate is oxidizing what all things. It is oxidizing these. Let's see what it is able to oxidize. So it is, you will learn like that, ki it is oxidizing iodide to iodine. It is oxidizing iodide to iodine. It is oxidizing SN2 plus to SN4 plus. Or you can remember like that, this one, it is oxidizing sulfide to sulfur. It's actually H2S. I have written sulfide. If you're not writing sulfide, it is fine. H2S also would be okay. This, you are oxidizing Fe2 plus to Fe3 plus. Okay, you are oxidizing it this way. Got it? Okay, so how you are going to balance it? This is again very normal. Balance elements other than O and H, that is iodine. And then electrons have to be balanced. This side charge is minus 2, this side is 0. So you will add 2 electrons. Let me balance each one. So means potassium dichromate has oxidized iodide to iodine. Potassium dichromate has oxidized stannous to stannic. This is simple, just we have to add electrons. This is also simple, we have to add only electrons. This is 0 oxidation state. This also you'll have to add electrons. And then you will have to add this equation, each of this equation to the dichromate equation which we already wrote. Okay, let me just copy that main equation first here. What was the equation? It is Cr2O7 2 minus plus 14 H plus 6 electrons give 2 Cr3 plus 7 H2O. So this is your main equation. So this equation you are going to add on to each of the equation which we wrote just now, making the electrons equal. So this is standard main equation. Dichromate is oxidizing iodide. So this you will multiply with 3 to make the electrons equal. Multiply this whole equation with 3 and add it to the first equation. So when we write down, the equation comes out to be, electrons anyway will get cancelled. If I multiply this whole equation with 3, what it will become? 6i minus, okay, it will become this equation which is already written here. Even this equation you will multiply with 3 because this is 6. This equation also you will multiply with 3. This equation you will multiply with 6 and add these equations to that first main equation. So when I am adding it, what will happen, children? Electron will get cancelled. So I am just writing this side the final equation. Okay. So now I am just adding and writing. Electrons will get cancelled. So first iodide wall equation, this will become as Cr2O7 2 minus plus 6i minus plus 14H plus, and electrons will get cancelled. You will get here 2 Cr3 plus 7 H2O plus 3I2. Okay, the electrons we have cancelled it. Got it? Now, you can just verify on your own the charges are correct. This side is 6. This side is 14. 8. That is 14 minus 8. 6. So, charge is correct. Each element is also correct. So, again you can add this equation to the first equation. what will you get? Cr2O7 2 minus plus 14 H plus, electrons will get cancelled. You will copy down this one, 3 SN 2 plus gives, again we'll copy that chromium, Cr3 plus 7 H2O plus 3 SN 4 plus. Now we will go on to the next equation. Again you add up this one, you will have Cr2O7 2 minus plus 14 H plus, electrons will get cancelled. So this 3 S2 minus is equivalent to 3 H2S also. It will give you 2 Cr3 plus 7 H2O plus 3 S. Again the last one you will copy at the fourth one, Cr2O7 2 minus plus you will have 14H plus 6 Fe2 plus, it will give you 2 Cr3 plus 7 H2O plus 6 Fe3 plus. Got it? So this is how actually what you have written in the pink color, no, that is the final equation. So you did not learn the whole equation as such, no. If you are learning it just like that, you are likely to forget. So what you will do is, you will learn in acid medium dichromate itself gets reduced to Cr3 plus, and if it is reacting with iodide to iodine, stannous to stannic, ferrous to ferric, sulfide to sulfur, and this equation separately you balance, this one separate and add it to that main dichromate equation. That's it. Got it? So with this I have completed dichromate. In my next video I will be explaining permanganate, that is potassium permanganate. Okay, thank you.